Hi everybody, welcome to looking again at the boundary of a surface on page 159 of your workbook. I hope you watched the 3D version of this where I demonstrated how to associate the orientation of a surface to the orientation of a boundary curve of that surface. And now we're going to look at the same or two of the same examples and one more using just a piece of paper, the flat version. So here you can see the definition of the boundary of a surface. So the boundary of a surface S is the curve, or possibly curves, C, running around the edge of S, like the hem-on clothing. Once an orientation for S has been chosen, the corresponding orientation for C is determined by the right-hand rule. So I demonstrated that in the previous video, and now we are also going to just repeat it on a piece of paper. All right, so we're looking at the same examples we looked at before. We have the cylinder, and the cylinder is open at the top and at the bottom. So we have two pieces to the boundary. So this is our surface S. And then the boundary curve is the top right here. So this is one piece of our boundary C. And then we also have another piece of the boundary right here. So both of those things together are the boundary curve C. Now, what is the orientation of the boundary curve? That totally depends on the orientation of the surface itself. So if I draw in a normal vector n to be pointing outward, so like this, if this is our normal vector, then using the right-hand rule, I can draw in, imagine my thumb is pointing in this direction, and then my fingers would be curling around this direction. And so that gives us the associated orientation of the boundary curve. Now, if you imagine I would continue curling this way, close to that bottom edge of my cylinder, my fingers would be curling around this way, and so I have the orientation in the opposite direction that we had at the top. So that was the outward orientation. If we are looking at inward orientation, that's hard to draw, but imagine it's pointing inward and is pointing inward. Then I would be pointing in and curling around this way. And my orientation of the boundary curve, which of course is the same boundary curve as before, it has these two pieces, would be exactly opposite. So for the top, it points to the right, and on the bottom, it points to the left. So you can imagine the curling going around this way. So that was our cylinder example. Let's look at our hemisphere. So that was a bowl, my metal bowl from the previous video. So I can have, again, an outward or upward orientation. I'm going to draw that on the left. So my upward orientation would be if my normal vector is pointing out or up from the bowl. Now, if I point my thumb in the same direction right here and curl, I'm getting curling this way. And so that gives me, for the edge, which is my boundary curve C right here, this is my boundary curve C, it gives me this orientation, pointing to the right for the close edge. And if you imagine the other orientation, the downward orientation, we still have the same boundary curve right here, the lip of this bowl. Then if you're curling, so you're pointing in, it's pointing inward, and you're curling and you're curling around this way. And so you would be, the orientation of our boundary curve goes in the other direction, pointing to the left. Now, I have one more example that we didn't have in the previous video. So we have a punctured yield sign. There we could imagine a normal vector pointing straight at us out of the page. So imagine over here, the normal vector is pointing straight at us. The boundary curve here has several pieces. So we have the outside of our yield sign, and then of course we also have that hole in the middle. So we have two pieces of this boundary curve. So all of that together is C, all those blue things that I just drew in, except for the dot. The dot is my normal vector. And now imagine the thumb is pointing out of the page and you're curling your fingers, you'd be curling this way. And so you can see the orientation very nicely for the different pieces of the boundary curve. So for that top line, it points to the left. For the left line, it points down, then it points up. And what about the circle in the middle? Well, if I kind of continue this, it is pointing counterclockwise. So we have a counterclockwise orientation of that circle in the middle. Now, if the normal vector was pointing into the page, I'm drawing the same picture, but you have imagined that the normal vector is now pointing away from, well, where my pen is right now. We still have the same boundary curve, of course. We have the three pieces on the outside, and then we have the circle on the inside. So those are our boundary curves still. But now we are like puncturing into the page and pointing the thumb that way and then curling our fingers. We would be doing something like this. And we get exactly the opposite orientation for all our curve pieces. Oops, drew that wrong. Okay. And we are getting counterclockwise orientation for the circle in the middle. I hope I said that right. So it's clockwise on the left and counterclockwise on the right. I might have said that wrong before. All right.